Hello friends, welcome to Coding Garden with CJ. Welcome to Code Katas number 8. Well, we're gonna break things down, one step at a time. We're gonna solve these katas, you and I. We're gonna break things down, one step at a time. We're gonna solve these katas, you and I. Code Wars, Code Katas, Code Wars, Code Katas, Code Wars, Code Katas, yeah. Welcome to the show. If you're watching live, please say hello in the chat, and we'll get right into it. So if you're not familiar with the show, I do post all my solutions to previous katas on this GitHub, github.com/codinggarden/code-katas. And tonight's episode, I do have links out to all of the katas that I plan to solve tonight. So let's click on them. Starting with, and they're going to get progressively harder. Mert-chan, welcome. Hello. So I looked up the pronunciation of your name. It's like the John, but with a CH a little bit, maybe? I don't know. You tell me if I'm right. But these are going to get progressively harder. So we start with growth of a population. Then your order, please, which is a 6Q. Then are they the same, which is a 6Q. Then rot 13, which is a 5Q. And then we'll end with a 4Q twice linear, which was, so the screen's already frozen, which was suggested by Mert-chan in the chat. Let me fix my frozen screen real quick. I hope I don't have to deal with this tonight. I haven't found a good time to go get it replaced. One moment, right? Okay, we're back. I think my screen is not frozen. Please let me know if it happens again. Apologies for that. But I'll show you the katas again. So we're going to start with the 7Q, growth of a population. We'll do a 6Q, your order, please. 6Q, are they the same? Rot 13, which is a 5Q. And then we'll end with twice linear, which is a 4Q, suggested by Mert-chan in the chat. This is a tricky one. It's worded very interestingly. I think I know what we're going to do. But we'll start with the easier ones and get progressively harder. So let's start with this very first one, growth of a population. And I'm going to open my soda. There we go. Okay. So this problem says, in a small town, the population is P0, 1,000, at the beginning of the year. The population regularly increases by 2% per year, and moreover, 50 new inhabitants per year come to live in the town. How many years does the town need to see its population greater or equal to P equals 1,200 inhabitants? So it shows there's like a simple formula. You take their current population multiplied by the percentage increase, add that to the population, and then also add the number of new inhabitants that move into town. And you get the total inhabitants. So you do this increasing the total population each time until you get to P equals 1,200 or greater. And so we have to solve this problem, but we're given the initial population, the percentage increase, and then how many people are coming into the city each year, new people coming into the city. And then P is the population that we're trying to get to. So we want to return how many years does it take to get to this given population. So I'm going to pull this code down locally so we can work on it there. Awesome. Let's take a quick stretch. I'm drinking a passion fruit LaCroix tonight. It's also starting to storm outside. You might hear some thunder. And also it's really hot in my apartment, so you probably hear a fan in the background. I apologize for that. Actually don't have any air conditioning. It's mostly okay throughout the day. Just some days it gets really hot. Okay. Let's create a file locally. We'll call this growth population. That's the function we're going to write, and we'll grab our tests. And let's just make these console logs. And what is our formula? This this is our formula. So current population plus current population times the percentage increase plus the number of new inhabitants. So that is the formula. And here's what we need to do. We need to keep track of how many years that we've done this. So a place to store the number of years and start it at 0. And then we will calculate this year's population. So calculate population with the formula. And then we will increase the year counter. And essentially, we need to calculate the population over and over until the total population is greater than or equal to p. So really, this could be like a while loop. So we'll say while population is less than or equal. Did I say greater than? We want to do this while this is less than or equal to p. And just repeat. And then at the end of all of this, we will return number of years. Sanjay, hello, welcome to the stream. So yes, that is what we will do. Let's do it. So first, let's say total, let's be a let total years starts off at 0 because we haven't calculated anything yet. And then we'll say while P0, because that's our current total population, is less than or equal to P, because that's what we're trying to get to. We're going to calculate the population. I see that my calculate got separated. Calculate, like that. And so our population, and really, let's store this in a function. We'll say get next population, and this will take in the current, and then we'll just do this formula. So we want to say current plus current times, and then percent is not, we can see it down here too, it's not a decimal yet, so we need to turn it into a decimal. So we'll say percent divided by 100 plus how much we're increasing each year, in this case is og. So that's the next population formula. So here we'll say P0 equals get next population with P0. And then we'll increase the total number of years counter. And we'll just keep doing that over and over. What is this complaining about? It's declared a value but is never read. Well, we'll return it here. Like that. There we go. So it's pretty simple. I think one thing that might be fun is to try to write this with recursion instead of a while loop, but let's see what this gets us. So we start at 0 years. We have a simple function to calculate the next year's population. While the population is less than our target population, I guess we could just say less than, not less than or equal to. Let's say less than. We'll use the formula to get next year's population, increase the number of years, and just keep doing this until it's either the same as P or greater, and then we'll return the number of years. Let's try it out locally. So if I do growth population, we did it. Cool. Let's try it on CodeWars. And Rodrigo, hello, welcome to the stream. And Shalom, welcome to the stream. Sample tests. It passed. Okay, so I want to try to write this with recursion. One thing, though, is because they're running tests against our code, we can't really add more arguments here. I guess we could. I don't know. Let's try it. Let's try to make this recursive using the function itself. So one thing I'll do is I'll move. Whoa, sorry. I'll move this function outside, and we'll also pass in. I guess pass in the percent and AUG. Okay, and basically instead of this while loop, we really want like a return statement. So let's say this. Let's say we take in total years. And when CodeWars calls our function, or even when we call it down here, total years is not going to have a value to begin with. Hey, Ron, welcome to the stream. One thing I totally forgot, though. Let's keep our existing code, and I'm going to write this recursively below it so we can kind of compare the two. So let's take this and do it here. I guess technically I can just leave that. Let's just leave that function there. But one thing I need is the total years needs to be passed into the function. And let's just say this. Total years equals whatever they passed in or 0, like started off at 0. And then we'll say if P0 is less than the population that we're looking for, we are going to say return get next population with P0 percent. Well, actually, let's do this. This will be tricky. Okay, so next population is going to be that. And then we actually want to return the function called again, but this time we'll call it with next population instead of P0. And then we'll pass in percent, we'll pass in AUG, we'll pass in P, and we'll pass in total years. And we will here say total years plus plus. This is very unfortunate. My screen has frozen again. I think I only wrote like 2 lines of code since it last froze. Oh. Okay, right back. Please don't go too far. My deepest apologies. I think we're back. Where's Dash? Dash is here. I actually haven't checked the fish cam today. Let's see. Does it work? It works. Cool. He's hanging out right behind the filter. There he is. Come on, buddy. Come say hello. Cool. Okay, screen is back. Please let me know if it happens again. I think that was painless enough. I can just kind of restart it. Okay, but here's the idea of a recursive function. We will keep calling this function until P0 is greater than or equal to P. And then in that case, we're just going to return the total number of years. And each time we're passing in one more year. So let's see if this works locally. We haven't broke anything. It works. Okay. We want the is it frozen? It's not frozen again. I don't think. Okay. We want the total number of times that this function ran. So I'm curious. The audio is stuttering? Everything's going wrong. Is the audio stuttering? I think someone confirm. I won't say anything for like 10 seconds. Oh, okay. Yeah, I'm dropping frames in OBS. I'll be right back. Okay, I think it's better now. OBS is not dropping any frames. My apologies, friends. I'm gonna work this out. It will be worked out. Everything will be great. Oh, I see. So JT is suggesting you essentially return 1 plus and then a call to the function again, because that will just be 1 plus 1 plus 1 plus 1. I like that, yeah, because then we don't have to actually pass in the total number of years. We're just keeping track of the total number of years as we go along. However, I'm curious though, what do we return when P is not less than 0? Let's see. Can't you just return 1 every time p0 is less than p? Oh, okay, and then return... zero? Huh, okay. So, oh yeah, because then it was 0 years. I get it. And it's going to be the sum of that, so it's all the previous years plus 0, because that was the last time it was called. That makes sense. Cool. Whoa, what did I do? Yeah, that makes sense, because ultimately we're just like building up this sum, and then lastly, we don't want to add anything more to it, and then the call stack just goes up and gives you all the previous return values. Very cool. All right, let's try this one on Code Wars and see what we get. All right, drum roll, please. That's really loud. Submit final. More drum roll. We did it! And much thanks to Wayne and JT for the recursive tips. Let's see how these peoples did it. They did a one-line for loop, which is very, very similar to what we did in our while loop. Cool. They did it with the while loop, and this person used recursion. So, and they did the opposite check that we did. So if p0 is greater than p, you just return 0. Otherwise, 1 plus a call to that function. Very cool. All right, moving right along. This next one, your order, please. So your task is to sort a given string. Each word in the string will contain a single number. This number is the position the word should have in the result. Numbers can be from 1 to 9. So 1 will be the first word, not 0. If the input string is empty, return an empty string. The words in the input string will contain valid consecutive numbers. So, for example, you get an input is to this with a 1 inside of it, test with a 4 inside of it, and 3a, which has a 3 inside of it. And then you basically have to take those words and sort them, so it should return the sentence, this with the 1 in it is a test, with the numbers in descending order. So let's figure this out. I will bring this down locally. New file. And we'll bring the tests down. Okay, how are we gonna do this? Our input string, well, our input is a string, and we're gonna have to look at each word. So we should probably split it on spaces. Let's take a quick stretch. Once we split it on spaces, we really need to sort it by finding like the first digit in the word, and that would be what we sorted it on. We could sort it as we go. So we could have, let's think about this. So we could have an array to store the sorted words. And first thing we would, well, then we would split the words on space. Then we need to iterate over the words. Find the first digit in the word, and then insert into the sorted array in the correct place. So for example, the first word we come across, we'll just put it in there. But then when we come across this word, we know that it needs to come before this word, so we'll insert it before that word in the array. And then we come across this, we can just put it at the end. Then we come across this, and we can just insert it before that word, because then it would stay sorted. I think that's what we'll do. And lastly, we will join the sorted words array on space. Okay, let's give it a try. So let's say sorted words is an array. We will split the words on a space. So could create a new variable. We could do like a for each or something like that. James just said over 1,400 subs. We are growing. We are growing here at the Coding Garden. I appreciate each and every one of you. Thanks for tuning in. Wayne Adams is saying, take advantage of the array index. Are you meaning the array index in the array after we split it on spaces? Are you meaning the array index? Oh, well, or the array index of the sorted words. Let me know what you mean. I'm gonna keep going down this path. I think initially I'll just do this with the for loop, and then we'll take a look at it again to see if we can use like a reduce or something like that. Okay, so let's say split words is going to be words.split on a space, and now we need to iterate over the split words. Well, I is less than split words dot length I plus. Find the first digit in the word. So let's say word is split words at index I. So this is going to be that individual word. And then we need to find a digit inside of that word. I guess we could use a regular expression. Yeah, John is suggesting a regular expression. And yeah, Wayne Adams is saying take advantage of the array index in sorted words. Don't know exactly what you mean, but maybe I'll see it when we get there. Whenever we're trying to put it into the array. But yeah, let's try to use a regular expression. So let's say digit word.match, and we can give it a regular expression that just searches for D, which is a digit. And right now, let's just log that out. Let's see what the result of matching it gives us. I'm going to run this with Quokka. No. I split. Okay, so let's also log split words. Okay, so that is going to be an array. And split words at index I should be this one. But when we matched with the digit, might have to look up my regular expressions. Is this not how you do a digit with regular expressions? Regex find digit. Look, I've Googled that before. /D, I guess. You have to escape it. Oh, of course, because otherwise you would think it was a D. There we go. And so if it matches, let's look at a result of a match. Then we get an array. I guess it might be an object. And we say array bracket 0, and that's our matched digit. So if we say array at 0, then that's our matched digit. And really, we want to make sure that, let's do this. 0, can't read property 0 of null. What? Oh, well. But I do want digit to be a number. Okay, so now that we have the digit, let's do this. Say let digit equal that, and then digit is digit at 0, and we will. Oh, if we're given an empty string, well, that shouldn't even go through here. Is it possible to have words that don't have a number in them? Let's see. If we split an empty string on space, we should end up with an empty array, right? Let's try it out real quick. If we say this dot split on the space, oh, we get an array with a single value. Let's just take care of that up at the top here. So, oh, really? I mean, and if an array has a single value inside of it, well, no, we'll just take care of it here. We'll say if not words, meaning it's the empty string, then just return nothing. There we go. And now we don't get that error anymore. So I now should be able to do this. So like grab the first result and then parse it as an integer. So we get ourselves a digit. And now we want to take this word and put it into sorted words using that given digit. And I think I see what you're saying now, Wayne, because we could, yeah, I like that. So we could do like digit -1 for the indice in the sorted array and then return that. So if we say sorted words at digit -1, that's going to equal the word. That's super easy. And we should always end up with, hopefully the tests on Code Wars aren't tricky and they don't give us like random numbers, but it looks like in these simple tests, all the numbers in the array are represented. So that's great. And then we should be able to return sorted words joined on a space. Look at us. Cool. All right, let's try it on Code Wars and then we'll write this. We could probably do this with a reduce. I think so. Sample tests. Okay. And let's try it with, oh, we're still logging. Let's get rid of that log. Sample tests. Cool. And then we'll attempt it. Hey! Appreciate that, Wayne. I didn't know what you're talking about till we actually got to it, but yeah, that's legit. Okay, let's write this with a reduce. I think we can use reduce because we're reducing this word in, well, yeah, the string into another string. We can use reduce. Let's use it. Okay, so this ultimately is what we want to reduce, the split words. So we're going to return it. And we'll be passing in the sorted words and the given word. And now we don't need that. And our accumulator will start off as an empty array. And then we'll do this thingy inside. Like this. And then we need to return sorted words. And then we need to join the whole thing on a space. Look at that. That's nice. Can you call? No, that should work because we're splitting on a space. Okay, very cool. I think I like this one. Trying to think, is there a way we could do it without splitting it and then joining it at the end? Because that's like 2 iterations. I mean, we could go over the string like 1 letter at a time. Is there a way we could use a regex? I don't know. I think I'm satisfied with this one, and we'll move on to the next one. We have some harder ones tonight. Attempt. Drum roll, please. Oh, I always forget to click the button twice. All right, submit final. Cool. Okay. So yeah, so this person just used a plain old sort function. This is not as performant as ours though, because we're doing it in a single iteration. But basically, they use the sort function to take one of the items, grab the digit out of it, take the other item, grab the digit out of it, and figure out which one is smaller, so they can order from least to greatest. However, because they're using the sort function, it potentially has some nested loopage in there, so it might not be as performant as ours. Merchan is asking, why is Code Wars so slow when submitting? My understanding is that they actually spin up a container to run your code securely inside of. I don't know if they do that all the time, but I'm pretty sure that's what's happening. And a lot of these katas actually have like a test suite with like hundreds of tests inside of it just to test it against a bunch of different cases. And so when people design their tests that way, that can take longer to run. But I'm pretty sure it's running your code in a container. Yep, they're using the sort. I'm shaking my head because like nested for loop, this right here was the trick, right? Like we have a single, well, we have multiple iterations, but we don't have any nested iteration, right? We're iterating over words to split it. We're iterating over words to create the sorted words, and then we're iterating over those words again to join them back together. Those are single iterations by themselves, and every single one of these I've looked at so far is potentially takes longer than that because it's comparing each other. This person did it, I think. Yeah. Oh, then for the win. Okay, so you changed some stuff. So, okay, split it on space, and then map over it to return the digit plus the given word. Ah, so it's going to put the digit. Oh. So that puts the digit at the beginning of the word to sort it. And then, interesting. I'm curious how they get the number back in there, though. Merchan says, I thought the tests were done when attempting the solution, though, not while submitting. I'm pretty sure when you do this, the final submission is when it's running it through more tests. I actually don't know. They might have written a blog post on it. It'd be interesting to read about. I kind of don't know what's happening here because if they're returning new words... Oh, I see. They're keeping the number in the word, but they're putting the number at the beginning of the word too. So when you sort it, now that the number is at the beginning of the word, the built-in sort just works by default, and then they remove that first number from the word, join it back together. Pretty interesting. Wow. Okay, let's keep moving. And James is saying they do it so they can offer faster if you subscribe to Code Wars Red. It could be the case. I mean, I think one thing is maybe if you do subscribe, they might spin it. Might give it a higher priority in the queue to spin up on a container. I was under the impression it's running on a container, especially because they offer so many different languages. Like you, not that I know of, you can't run C# in the browser. So like they actually spin up a container that has that specific environment in it. You could probably run C# in the browser, but specifically for this, they spin up a container with that environment, run your code and your test against it, and then spin it back down. All right, moving right along. Hey, Amal, welcome to the stream. Okay, are they the same? This one is a 6Q. Given two arrays, A and B, write a function compare of A and B that checks whether the two arrays have the same elements with the same multiplicities. Same means here that the elements in B are the elements in A squared, regardless of the order. Okay, so A is an array, and then B is another array that has potentially some value from A inside of it squared. So the comparison of these returns true because in B, 121 is the square of 11. 14641 is the square of 121. No, 121. And so on and so on. So each of the numbers in the second array is a squared version of a number in the first array. Okay. Very good. Very good. Remarks. A or B might be empty. A or B might be nil, null, or none. A or B, if A or B are nil or null or none, the problem doesn't make sense, so return false. If A or B are empty, the result is evident by itself. False. Yeah, okay. Okay. All right, let's do this. New file. What are we going to call this? Are they the same? Are they the same? Boom. One simple test. Let's put some const on there. Okay, so we have this array. This is going to have the numbers that are not squared. Is that what they are? Yeah, because it's the number times itself. It's the number to the power of 2. Oh, and before I begin, James has an answer. Your code will be executed on a member-only cluster with lower demand and additional isolation. Requests will be better protected from any code outages and slow responses. So, if you are a, Code Wars Red member, then they have a separate set of machines, or like, I think they're containers. It's in the cloud. They're machines in the cloud that run your code, and you can pay to have better ones. I don't know. Okay, so array 1 will be the array with the numbers that aren't squared, and then array 2 will be the numbers that are squared. Okay, here's what we need to do. So let's do this. Let's build up an object of all the numbers in A2. Wait. We want to return true. First, let's take care of our default logic. So like, if not array 1 or not array 2, meaning if either of them are nil or null, we'll return false. Or array 1 dot length is 0, or array 2 dot length is 0. Oh god, sorry. Or array 2 dot length is 0, or array 1 dot length does not equal array 2 dot length. In any one of those cases, we will return false. Okay, let's clean this up a little bit. So that, or that, or that, or that, or that, we're going to return false. Okay, now we know that both arrays are the same length and they actually have some stuff inside of them. So one thing I want to do is build up an object so that way we don't have to search through the array again. We can just say, hey, is this value inside of there? So let's do this. Let's create an object where the keys are the squared values and the oh, I just thought of a case potentially where, oh no, it should fail anyways, I don't know. Merit Sean is asking, isn't an empty array already a false statement in JavaScript? I don't think so, because it has a value. If this, I don't think it's falsy. I may be wrong. Is a thing. So arrays are not falsy. And that's mainly because they're like an object that has a value inside of them. So I think I demonstrated that right. We'll see. We'll see if I run the tests. So create an object where the keys are the squared values and the values are true. So basically, we're going to end up with an object that's like, well, let's get the squared values, like this one. So we're going to end up with an object where we have like 121 true, true, 14, 641 true, and then etc. So we'll have an object where all of these values are set to true, and then we'll iterate over this array. We'll square the value, see if it's in the object, and if it is, keep going. If it's not, we're done. It wasn't a thing. So okay, we have that. Now iterate over the first array. If the current value squared is not in the object, return false. And then if we made it out of the for loop, return true. All right, let's do it. So we need an object to store the squared values. So let's say squared values will just reduce this second array into an object. So we're going to get the values and the given value. And we want to start this reduce at an object. And every time we are going to return the values. And, ooh, what happens if it's in there twice? Is it in there twice? It is in there twice. Oh no! I guess we could create an array and push it in there. This is where it gets tricky. Oh, we'll put the count. We'll put the count in there, and then we'll decrease the count. Okay, so else decrease count. Okay, so here's what we'll do. We'll say values at that given value is equal to itself or is equal to 0. So if it wasn't in there, put it in there as a 0, and then just increment that. Okay, so now we should have an object with all of the squared value counts. So let's just log it to see what it looks like. Turn on Quokka. Cool, so we got an object. 361 was in there 3 times, 20,736 was in there twice. So we now know how many times those squared values occurred. Now let's iterate over array 1. Let's write this with the for loop, but then I think we can use a higher order method like sum or something like that. Yeah, and Merchon is suggesting sort both arrays, square the first, and then see if they're the same. I think I'll show that, but as you mentioned, it's not as performant as this because we have to sort it and then iterate over to compare it. Okay, so let's just do a for each because why not? So we'll say array1 for each value. And we'll create a value squared. If you did not know, in I think ES7, they introduced the exponentiation operator, so you can actually raise a value to a power, which is pretty cool. I think my editor doesn't recognize it, but that should work. If the current value squared is not in the object, return false. So if squared values at value squared not. So if it's not in there at all, just immediately we're done. No need to even go any further. Done. Else, oh, we also need to check. We also, if it is in there, then we could delete it. I don't know. If it is in there, then we need to make sure that the count isn't 0. But, well, okay, we'll do that. So otherwise, we'll take squared values 0 and decrease the count. So we need to check if it's not in there, or if it's in there and equal to 0. Actually, that would work because a 0 knotted would be false. So that technically would work. And if we made it out of the loop, return true. All right, true. Seems to work. All right, I'll give this a try, and then it'd be cool to see what the sorting them and comparing them looks like. Sample tests. Oh no! Oh, okay. It's using Node version 6, so it doesn't have access to the exponentiation operator. Oh no. Did something wrong. What about the sample tests? That should pass. Okay. And then in the case where it doesn't, let's log the two arrays. James, yeah, that is what Merit-John suggested. Sort them, compare them. If they're the same, then we know they're good. Array 1 and array 2. Yeah. Okay. Expected false, but got true. Let's see why. There's 1, 2, 3, 4, 5, 6, 7, 8 values in the input array, and 1, 2, 3, 4, 5, 6, 7, 8 values in the output array. Oh, good call, Wayne. That is why. That is exactly why. Yeah. If you return a value from inside of a for each, it does not exit, which is why I actually do need to use a higher order method or a for loop here. I'll use a for loop first, and then show how to do it with a higher order method. But yeah, you're absolutely right. That's what I was thinking to myself whenever we did this, because then otherwise we wouldn't break out. So yeah, so let's create a for loop. We're gonna go over array 1, and we'll say value is equal to that. And this is what we want. We'll want array 1. So inside of a for loop, if you return false, it will break out. James is suggesting some interesting things. Sum both arrays and then square the first one? Interesting. But yeah, this still works. And then there is a higher order method we can use, so we'll try that. Sample tests. Okay, attempt. Oh no! It failed for one case. Let's see why. We'll log the two input arrays. There's no log. Yes, there are maths involved. This is very tricky. So for whatever reason, there is no log for when the test failed, so I can't really see what's going wrong. Let's take a quick stretch. Weird. Maybe I'll double check my... Let's actually read the problem. Maybe if both arrays are empty... Merchan, only one test failing is the worst failing ever. It is, because everything else passed. My guess is maybe if both of the arrays are empty, then it wants it to be true. Because technically they're both present. So let's... How do we test this? Okay. So if array 1 or array 2 are null, don't even try. If... Yeah, we could write like a more complex. If array 1.length is 0 and the other one's length is not 0, oh really? I guess we just need that. Yeah, just compare their lengths. Because if they're both 0, then it should be okay. Let's try that. Oh, issue with my... Yeah, and I think that's what I'm thinking. I think we should console log above it. If this doesn't fix it, then I'll move the console log. But I think that's why. Oh, that was it. Okay. So it was because both array 1 and array 2 were empty. Pretty sure. Let's move our let's console log up here so we can be sure. But yeah, that was probably why the console log wasn't running before. Hey, yeah, that was why. Okay. Okay, very cool. All right, let's try like sorting it and doing other weird things. Oh, also the higher order method that we can use right here instead of a for loop. Okay, let's copy this. So on the array prototype, there's a thing called sum, and there's also a thing called every. And the sum method tests whether at least one element in the array passes the test implemented by the function. We probably want every, because we want every value, and maybe we could like return true when we decrement it. We want every value to return true. The moment one of them returns false, then we return that. Every. Method tests whether all elements in the array pass the test implemented by the provided function, and this will actually exit early the moment one returns false. So let's try to do that. Let's say array1.every, and we'll give it a function that gets the value, and we'll do this inside of it. And we'll return true in this case where we decrement it, and then we'll just return this whole thing. So if the value wasn't in here, return false, and then the every will immediately break out because not every one of them returned true. Otherwise, every single one returns true. Should do the same thing, but it's a little bit nicer. Oh, not all of it. I only want to here. Okay. Okay, cool. Every element in a squared, which is nothing, is actually equal to exactly. And that's where I went wrong earlier with just checking if either of them were 0. Okay, so let's try what was suggested earlier. Sort both arrays, square the first, and then check if the first equals the second. Okay. So we definitely need just like the same basic check to begin with. We will sort, let's say, squared sorted is going to be array2 dot sort, and then what do we call this other thing? Like just values, I guess. It's probably a better name. Values sorted is going to be array1 dot sort, and then we could map over it, and then each value will return value times value. So we're going to square every value, and then we need to compare two arrays. In JavaScript, you can't, well, in most languages, you can't just compare two arrays. You can't do this. You have to actually look at each value. So let's do that. I think one thing we could do, actually you could do .toString. So turn the, so okay, here's what we do. So first array, sort it, and then map over it to square each value. Now values squared and sorted. And then array 2, we just sort that because it's already the squared values. And then we compare the two by turning them into strings. Let's see what happens. I might show how you, I mean, to compare two arrays, you literally have to iterate and compare each value. This turns it into a string, and you can do comparison of strings, so that works. Works for the sample tests. Ooh, it failed for a few. Testing for 88, 34, 64, 35, 7, 38, 28, 32, 47. Let's see what happens when we do this locally. So if A1 is that, and A2 is that, we get false. Why do we get false? Okay, let's actually iterate over these words. We actually could use an every. So let's say if every value in value squared and sorted, you want to return, does the value equal, and we also get access to the index here. Does the value equal squared sorted at that given index? Huh. Getting false. Sorting after squaring. Oh, I am not doing. No, I'm not. I am sorting it then squaring it. Well, negative values squared or positive. Let's do this. Let's map it then sort it. That could be why. Yes, that is why. Good call. Another suggestion from James, like after we squared it, sum it. Well, I guess that could work because after it's squared, if both of their sums are the same, maybe not though, because there could be some values in the second one that like somehow add up to be the values in the first. I don't know. I'll leave that there. Let's also test it with comparing as strings. All right, let's see if this works. Why would that change anything though? That works. Why did moving the sort after the map fix that? When you square a value, it's always going to be greater than the value below it squared, right? Huh, I don't know. But, so I'm going to submit this one, the one where we create the object and then do every. Of the solutions we looked at, this is probably the most performant because this will iterate once over array 2, so that's one iteration. And then this will iterate up to one time over array 1. And because we already turned this into an object, we don't have to search it for the given squared value. We're just using instant object access notation to say, hey, does this object have that inside of it? So this is pretty performant, whereas sorting can take a little bit more computing power or number of operations to do, and we're sorting 2 different arrays twice, so this takes a little bit more operations. Oh, yeah, that could be it, Wayne. The sort acts on digits. Well, yeah, because I think that's it. Like if we look at, let's look at what this looks like sorted. (28, 34, 35). Yes, because the 7 gets put in between the 66 and the 83 because it's sorting them as strings. Ah, okay. So and this would happen the same thing with negative values. In our case, though, we weren't testing with negative values. It's the fact that the built-in sort doesn't handle numbers. To make it handle numbers, you have to tell it how to do that. So you have to say, given these two things, return A minus B. And that actually sorts it based on maths rather than based on their ASCII codes. Okay. And we'll do the same thing here. Well, stored in a function. Sort nums. Cool. I am going to, as I said, submit this one, though. Oh, speaking of ASCII codes, lexicographic sorting. But speaking of ASCII codes, ROT13 is going to have us deal with ASCII codes, so that'll be interesting. Attempt. Yeah, so the one we went with was first basically make a dictionary of all the squared values, and then iterate over the non-squared values and see if that value squared is in the object. If it's not, we immediately return false. Otherwise, we return true. All right, drum roll, please. It takes so long. I ranked up. I'm a 4Q. Yay. Cool. That was fun. All right. Let's see how some other people did it. Yep. Okay, so this person sorted the two arrays. Sort both arrays, then every is a way. Yeah, I guess that's what I did that. Yeah, I created an every to do the comparison between the values. The other way to compare arrays is to turn them into strings. This probably is not very performant. Probably want to do the every. I don't know. Okay. This is like a nested loop in disguise because they're using this index of. And I guess they had to do tricky logic because there are cases where the squared value is in the other array, but the value not squared is in the array twice. So the squared value actually needs to be in the array twice. So they're actually like removing that index out so that they don't see it again. And then also using index of has to search through the whole array every time to find that value. Whereas if you build up that object first, you don't have to search through the whole array. Map it, sort it, join it. And they're basically doing a string comparison because they're joining the array on the empty string. Doing toString, I guess I'll show you what that looks like. Let's take a quick stretch. Oof. Yeah, if you toString an array, it just automatically separates it by commas, I believe. Yeah, you get a string with the array values in commas. So basically, when we did this, it's just comparing two strings. All right, moving right along to ROT13. This is gonna be fun. Okay, ROT13 is a simple letter substitution cipher that replaces a letter with the letter 13 letters after it in the alphabet. ROT13 is an example of a Caesar cipher. Create a function that takes a string and returns the string ciphered with ROT13. If there are numbers or special characters included in the string, they should be returned as they are. Only letters from the Latin or English alphabet should be shifted, like in the original ROT13 implementation. And if you're using Python, you can't use encode because apparently that has it built in. Cool. All right, let's do it. I'm going to create a new file. Just like that. I'm getting like really weird syntax highlighting in code. I'm just going to quit it, open it back up. Okay, yeah, notice that was gray earlier. It's pretty much the only issue I have with VS Code. It, what do you call it? If I leave it open for long enough, the syntax highlighting gets weird. So let's try this out. Oh, it's case sensitive too. Okay. I have an idea how to do this, and it's going to be with dealing with ASCII codes. I'm going to do this. Okay. So right now, if we run this, undefined, because we're not returning anything. So here's what we want to do. We need to look at each individual letter and then move it 13 characters up. But for this, we can use ASCII codes. So let's look those up. JavaScript ASCII codes. Oh, Merchan is saying I can reload the window instead of restarting. Quick detour. Window tasks. Reload window. Oh, okay. Yeah, I'll try that. From char code. So we're definitely going to use this because we can pass in an ASCII code and get back a string letter. But I want a list of the ASCII codes because we need to ignore anything that's not in the alphabet. And lowercase a through z are in a specific number range, and then uppercase a through z are in another specific number range. So I want to be able to check for those. HTML ASCII reference on W3 schools. Okay, I guess I'll use W3 schools for something. Right, okay, so capital A starts at 65, goes all the way up to 90. So we want to check between 65 and 90 on the given letter. So let's make a note to ourselves. 65 to 90 is uppercase letters. And then our lowercase letters are 97 through 122. Our lowercase letters. Okay, so here's what we need to do. We need to iterate over the message. And we then need to get the char code for the current letter. If it is within either range, it's going to be tricky, but we need to shift by 13. It'll be easy for anything below, what's 90 minus 13? Anything below 77, perfectly fine. Anything else, we have to wrap back around to 65. Same thing with 122. So anything below 109, we can shift it up 13, no problem. But if it goes above, we need to wrap back to 97. We'll figure that out when we get there. And then append shifted letter to the encoded string. And we also need a place to store the encoded string. Cool. Amal says I'll have to do it for both upper and lower. Keep track of case. JT says good time for an anonymous function. I might use an anonymous function somewhere in here. All right, and then after we've done all that goodness, we can then return the encoded string. Okay, so we'll start off with encoded. Oh, and the whole reason I wrote down those ranges. So if it's in either range, shift it by 13. Otherwise, just append the current letter to the string. Because if they pass us like a number or an ASCII code, we just, or not an ASCII code, a special character, like any of those, we'll just append it. Okay, so we need a place to store the encoded string. We'll call this encoded. Start it off as an empty string. Iterate over the message. So let's just do a for loop. I is less than message.length I plus plus. And then we will get the char code for the current letter. So let's say, let's just say letter is message at I. And the char code is going to be letter dot char. Oh no. String dot char from char code. No. We should be able to say char code. Char code at 0, I think. Well, then again, we could just use I. Let me test this in the node REPL. A dot char code at 0. Yeah, so let's just do this. We'll say message dot char code at I. So that will give us the ASCII character code at that given index. Amal is asking, how will I resolve both ranges? Don't know yet. I'm going to do it, though. So basically, I'll just have to do some math. If it goes above 90, subtract it from 90, and then add it to 65. If it goes above 122, subtract it from 122 and add that to 97. I think that's the math. Okay, so we'll say if char code is greater than or equal to 65, or char code is less than or equal to 90, we've got ourselves a lowercase letter. So we're going to shift it by 15. I'll go ahead and write out these if statements. Else, if the char code is greater than or equal to 97, or the char code is less than or equal to 122, we've got ourselves, oh, sorry, these are uppercase letters, these are lowercase letters, so we will handle that. Else, we're just going to append, that goes there, that goes there. Else, oh geez, sorry. Else we'll just append the current letter to encoded. Okay, so we'll say encoded plus equal the current letter. All right. We need the new char code. And this is going to be the current char code plus 13. Okay. Should it be and? Yes. Yes. If the char code is greater than or equal to 65 and less than or equal to 90, that means it's in that range. Yes, because otherwise, well, yeah, because otherwise, if it was less than, if it was greater than or equal to 65, but also greater than 90, it would still work. So we definitely need and. Good call. And so modulus, I'm trying to figure out how we would use modulus because we need the, okay, so our new char code is char code plus 13. So basically we have to check if the new char code is greater than 90, then we need to wrap it. Let's do a let. Let me write it this way and then maybe subtract the minimum value. Oh, okay. With a modulus? Write out what you mean. I'm going to write it the long way, and then I'll convert it to a modulus. So new char code is greater than 90. We'll say new char code will be 64 plus new char code minus 90. I think. And then once we have the new char code, we're going to append that to encoded. So we'll say encoded plus equal string dot from char code new char code. And then we got to do the same thing here. but we got to check for different things. So if it's greater than 122, we'll say 96. We may have to do, I think we go lower, minus 122. All right, Quokka, what do you got? I broke a thing. Unexpected token. Else if. There you go. Oh, and then we're not returning encoded. Hey, I did it. Okay. Should be so it worked, yeah. So when we're testing it with lowercase, we get lowercase, but when we test it with uppercase, we do get uppercase because we're handling the uppercase and lowercase cases. So JT is saying subtract the minimum value of the modulus. I guess maybe I'm doing the opposite. So if we do the new chart code mod what would we be modding it by? Okay, I appreciate you typing on your phone keyboard. Char code minus the min value plus 13 mod the y26 plus min value plus 1. That's a lot of maths. Okay, I'll submit this one, but then I'll try that. That's super interesting. I really appreciate you typing that out. Okay, let's try it. Sample. Works for the sample. Do the bigger attempt. And it works. Cool. All right, let's try this modulus stuff. Oh, 26 letters in the alphabet. Cool. Of course, but of course. Okay, so we can actually we should be able to just throw the maths right in here in the char code. So we'll say char code. Actually, let's write a little function to do it. We'll call it JT. Let's JT that char code. But we also need to pass in the min value. And in this case, the min value is 65. And here, we'll do that with the min value of 97. All right, let's JT it up. Nice little anonymous function. This will take in the code. We'll take a quick stretch. I see. Map it in between the range 0 to 25, modulus 26, and then add 1. I like it. Because basically between 65 and 90, that is 26 numbers because there's an alphabet there. Okay. So we need, we're getting the code and the min value. And rot 13 of a rot 13 message is itself, because half of 26 is 13. So if you if you do it again, then it goes back around. That's pretty cool. Okay, I can do this. Parentheses, code minus the min value plus 13 mod 26 letters in the alphabet plus min value plus 1. Let's see. I think we're off by 1. So, is it minus 1? Nope. Here, should I be passing in 64? GH. We went 1 letter too far for each of these. So, do I need to make it that? Nope. So, oh, it needs to be code plus 13. That's why. Oh, wait. No, it doesn't. Only add 12? That fixes it. It's because we're adding 1. But then what's the 1 for? I've been coding for an hour now. Don't exactly feel like explaining it, but it needs an extra -1 before the mod. It seems to be working now, though. Oh, if we did... now we're getting weird characters. But if we did that as 13... Well, and then we don't add 1... No. I'll leave it the way it was. Cool, that seems to work. Okay, cool. Let's get rid of these comments. Yeah, I'll leave that like that. The 1 corrects a 0. Okay, it's because we're mapping from 0 to 25. Makes sense. All right, I'm going to submit this version. It's a little bit more verbose, but if you look at that long enough, it makes sense. Basically, you're taking this range, changing it, or mapping the new value between that range by putting it between 0 and 25. Right. I like it. Oh, and just to see, if we rot 13, a value that was rot 13, we should get back the value itself. Huh? Huh? Look at that. Okay, cool. Submit final. If you look at that long enough, it makes sense. I say the weirdest things. I mean, depending, it may or may not make sense. Okay. Oh, look at this. They've got a shifted alphabet, so that works. We're just doing maths. String.replace any character A through Z. We're going to replace that with replace accepts a function? I guess we've never really done that. So you get access to, as it's looking at each individual value. We're going to grab the char code. Interesting. So they take the current char code. If the letter to lowercase is less than or equal to M, then they're going to add 13. Otherwise, they're going to subtract 13. I don't want to look at this for too long. We're going to move on to this last one because it's a doozy. Submitted by Merchan. Okay. Here we go. I read this one like 5 times over and still couldn't figure out what it wanted, but I think I know now. It's just worded in a very mathy, very interesting way. Take a quick sip. Consider a sequence U where U is defined as follows. U of 0 is 1, and this is the first one in U. For each x in U, then y equals 2 times x plus 1, and z equals 3 times x plus 1 must be in U2. If there are 3, there are no other numbers in U. So, for example, if your sequence starts off at 1, by plugging 1 into this formula for y and z, your sequence now has 3 and 4. Then you plug 3 and 4 into this equation, and you get 7 and 10 and 9 and 13. So essentially, you're building up this sequence, but each new number you add, you have to run through this equation and this equation, put it back into the sequence, maintain a sorted order, and essentially just keep calculating values. So 1, which is what we started off with, if you run it through those two formulas, gives 3 and 4. 3 gives 7 and 10. 4 gives 9 and 13. 7 gives 15 and 22, etc., etc. So our task is given in. We need to find the nth number in the sequence. So we need to essentially perform this operation on all the numbers n times and grab that number, the nth number, from the input array. So double linear of 10 should return 22. So if we look at this, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 is 22. So double linear of 10 would give us back 22. So essentially, whatever input number they give us, that's how much we have to calculate up to, and then grab the calculated value at that index. Let's do it. Okay, we'll call this one twice linear. That's what it's called, but twice linear. We'll bring down our examples. Let's start up Quokka. All right, right now we're getting undefined because we're not returning anything. But essentially what we need to do, we need a place to store the sequence. We should probably start the sequence at 1. We need to keep track of how many times we've done this calculation, and that number will count up to n. Once we get to n, we'll return the nth number in the sequence. Each time before we increment our count, we need to calculate y and z, and then we need to put those values into the sequence. Okay, so we need a place to store the sequence. Sequence, yes. We need a place to keep track of the count. Let's call it length. And I think that's pretty much it. So then we'll say, like, while the count or the length is less than n, we are going to, and actually, let's do this. We will start the sequence at, with 1. So that's going to be our first x value. And then we'll keep track of where the current x value is in the array, because one of the tricky things about this is, first, 1 is our x value. It calculates 3 and 4. So the next time around, our x value needs to be 3. And then that will calculate 7 and 10. And then the next time around, 4 needs to be our x value. So we'll have an index that will keep track of what our current x is. So a place to keep track of current x index, set to 0. Place to keep track of the current length, set to 0. While length is less than n, we will calculate y given the current x. We will then insert y into the sequence. We will then calculate z given x, given the current x. And then we will insert z into the sequence. We will then increase length and increase the z index, the x index. And then after all of that, we will return sequence at the given in. Okay. One of the things, though, is whenever we insert a value into the sequence, we want to put it in sorted order, right? Because, for instance, 1 generates 3 and 4, and then 3 generates 7 and 10. So those are in the array. But then 4 generates 9 and 13. So when we insert 9, it actually needs to come before 10. So we'll insert y into the sequence in sorted order. And z into the sequence in sorted order. All right. I think that's our basic pseudocode. Let's turn this into real code. So let's say our sequence is an array starting with 1. So we're going to start there. A place to keep track of the length and set it to 0. So we'll say let length equal 0. A place to keep track of the x index, set it to 0. Now, while length is less than the given n, we will do these things. Let's kill Quokka for a second. Calculate y given the current x. So the current x is just going to be our sequence at the x index. So we'll say x is sequence at the x index. So on the first iteration, 1 is our given x value. Calculate y given the current x. Say y equals get y with x. We'll then write a function that does this. So get y is a function that takes in an x and returns 2 times x plus 1. We'll then insert y into the sequence in sorted order. For now, let's just push it in. So let's say sequence.push y. Calculate z given the current x. So z is going to be get z with x. And then we need another function for z, which will be this. Oh. So we want to do take in x and return 3 times x plus 1. And then insert z into the sequence in sorted order. Let's just push it into the array. Increase the length. Increase the x index. I like it. So I'm getting some suggestions in the chat. You can sort only at the end and get away with it. Might depend on your algorithm. And Wayne, that was from Merritt John, and Wayne is saying append both and then sort after each n. I guess we could also sort after the current x. But yeah, let's do this. So insert y into the sequence in sorted order. Let's just write a simple function to do that. So let's say insert sequence sorted. And this takes in the given value that you want to put into the sequence. And we'll just do a for loop that goes over the sequence. And the moment we find a value in the sequence that's greater than our current value, we'll just splice this value into the sequence. So let's say if sequence at I is greater than value, then this is where we want to insert it. Let's do this. We'll use a var so that way it'll exist outside the for loop. Then when we break out, we'll just say sequence.splice Splice takes in, where do you want to splice it? I. How many do you want to delete? None. What do you want to put in there? Value. So that the moment it finds a value greater than what we're trying to insert, it breaks out, and then we just splice it into the array. So we could call that, instead of pushing it, we'll just call it here. And here we'll call it with z. We forgot to increase the x index. Wayne is asking, do we need to manually keep track of the length? The weird thing about this one is, like, the value 21 and 27, I guess, don't show up until after 22 was inserted, and then, like, 22 is the answer in this case. Because the given in is not the total length of the sequence. It's the number of things we need to calculate. I don't know. We'll see. This one's tricky. Okay. And then return the sequence at n. So return sequence at n. All right. Let's see what happens. And I guess just to clarify, Wayne, do you mean potentially using like sequence.length? I don't. Maybe you've confirmed. I'll keep going. Okay. Quokka. Let's try it. Okay, it works for the first one, but does not work for these other ones. Let's see what's going wrong. So. Let's just log our sequence before returning it. We have duplicate values. I think that's the main thing. So we can't just go inserting anything into it. We need to keep track of what we've inserted. Yeah, like 94 shows up twice, 31 showed up twice. I guess in this first case, it didn't matter because we were only looking for the 10th value. But in this case, we expected 57, but 31 showed up twice before that, so we didn't actually get what we wanted. Okay, so we need to keep track of what we have actually inserted into the sequence. So let's just use an object for that. We'll just say, like, I guess technically the sequence could be a set. We can just add it to the set. I don't know, does a set maintain order? I'm just going to use an object, just because this is kind of similar to what we did earlier with like the squared numbers. Our object kept track of every squared number that we saw. So we'll just keep track of every number we insert into the sequence, and if we've already seen that number, we won't insert it. So let's say before we insert sequence sorted, we'll say if we have not seen y before, then do this. And we'll say seen at y is true. And then similarly for z. And seen at z is true. All right, that's getting what we want. Let's try it out. Mayur is asking, what is the problem statement? Just joined. Yeah, so that's the link from Merritt John. Basically, it's a very interesting math problem. Let me see if my code works, and then we'll do it there. But yeah, JT is saying our sorted insert can handle that. I mean, I guess technically we could just check at the top of insert sorted sequence, like, have we seen this before? Yeah. Let's do that, because then we don't have to have it twice in our code here. That. And now our insert sorted sequence will just basically check right here. So we'll say if we have seen the value, just return, move along. And then here we'll say seen at value equals true. Yeah, because if we've seen it, we don't want to insert it. And if we haven't seen it, we do insert it, then we set seen to true. And that still works. All right, let's give it a try. Sample tests. All right. We'll do an attempt. It's taking a while. Okay, one error. Execution timed out. Okay, I think this might be the suggestion is only sorting at the end. Because right now, like every time we insert a value, we start all the way at the beginning of the sequence. And for things like 100, there are a lot of values in there. So we could just keep track of where is the last place we inserted something and start there, because we don't need to check from the beginning every time. And that's probably what's happening, because like for these random tests, they probably give us like really big arrays. Yeah, value 246,909. So that's going to be a gigantic array. And if we're searching the whole array every time, it'll definitely time out. So let's create a variable like last insert and start that at 0. And we'll say, and we only care about, I guess, the last insert, because each new value we calculate will be larger. Or will it? Not for z. We might have to fix that. Okay. But whenever we get to that specific I, we'll say last insert is equal to I and break. And then we'll insert at last insert. And now we can make this like a let. Okay, does this still work? It does not. But I think the reason why is with z, because when we insert with z, it's actually going, it's always going to be the end of the array, because z is always going to be like the biggest number possible. So we should just push z into the sequence, because every z will always be the largest in the array. Right? Right? I think so. Right. Sequence.push z. Because that way we're not setting the last index, and now the last index is always possibly the smaller value. That broke too. Okay. Because now we need to say seen z also. We don't want to calculate multiple z's. No? Okay, it's breaking big time. Let's go back to where we were and figure out how we can keep track of that last inserted value. JT is suggesting a binary search. Binary search the sequence. I guess like store the sequence as a binary search tree, and then at the end we flatten it. I don't know. Okay, so that's back to working. But I don't always want to iterate from 0. Let's try this last insert thing. Actually, let's do this. We only care about the last insert when it was a Y. I'm pretty sure. So if this, let's have this function just return the index that it inserted it at. And we'll start this at last insert. It's always starting at 0. It still works. But whenever we insert a Y, we're going to say last insert will be the returned value there. And that breaks. JT is saying, yep. So create a binary search tree, use that for our inserts, and then flatten it to get the nth value. Would I have to implement a binary search tree in JavaScript, or is there one I could use? Or I guess because they're sorted. Wait. I don't know. Do we want to do like last insert -1 possibly? That might be it. You can try something like next x equals 2 times the sequence at x plus 1, so you don't need to check multiples. So we're essentially calculating like the next 4 values on each iteration. Is that what you're saying? Let's do this. What if we search from last insert -1? And here we say last insert is that. It breaks. Why does it break? Let's do this. I want x is 2 times x plus 1. So next x is 2 times sequence at x plus 1. So I guess what you are saying, though, is we're essentially, instead of just calculating 2 values inside of our while loop, we calculate 4, and then we can keep track of what got inserted, because that's where our duplicate values potentially will come from, and then increment by 2 every time. Let me try some things. So we do want to keep track of last insert. I think one thing is, though, I don't think we need to do the insert sorted sequence for z. We really should only do it for y. So if we haven't seen y, then insert y sorted. And then z, we should just be able to push into the end of the array. So like sequence.push z. Let's take a quick break. See you, James. Have a good night. Does this work? Okay, this broke. Oh, do we need to check for scene z? Oh, we need to put scene at z is true. There we go. So this still works. Now, oh, okay, now I just need to set last insert, right? Last insert is I. Yeah, I think I did it. I moved some things around, but basically, we always know that the z will be the largest possible value, so we just push that into the end. And I think I got it working, though, Mirchan. Audio is crackling? Okay. I'll be right back. Okay, I think we're back. Yes, Mirjan, I think I got it working. I might try what you're asking me, but I think I got it working. So, and the main thing is we need to test this on Code Wars to see if it doesn't time out. But now we're keeping track of the last insert. So anytime we insert a value, we set last insert equal to that given I. And we stopped using insert sequence sorted for Z because Z will always be the largest value. And then we just carry on like that. So let's see if this fixes the timeout. Okay, so still runs for the sample tests. Cross your fingers. I guess I do have to do one last final attempt if it works. Oh, it timed out. Saying it took 12 seconds. Let's see. We are keeping track of the last insert there, though. Like if I log last insert. One, 3, 4, 7, 14, 16. So the array, like, well, the insert is always starting at the last place that it got inserted. So that's a good thing. Okay. I don't know any way to make it faster though. I'm wondering if your suggestion, Mert-Jan, will be faster than this. I don't know. Let me just try submitting again. Attempt. The definition of insanity is trying the same thing over and over again and expecting a different result. No, it's timing out. Okay. Oh, I see what you're saying, though. I think I see what you're saying. So inside of our iteration, we're calculating next x and next y, and only pushing in the larger one, and then doing that every time. I might give that a try. It's a totally different solution. I also have been streaming for... I think that's wrong. It's at least an hour and 40, I believe. So I might end it there. Let's see. See you, Wayne. Thanks for tuning in. Have a good night. Okay. Let me just take one more last once over and see if there's anything I can do to speed this up. So, these are all constants. Very, like, I guess instead of putting it in a function, if we put it in line, will that make it faster? It might actually make it faster. Because a function call... is that... and then... yeah, let's just see that. So by not having to call a function every time, will it be any faster? Attempt. I'm grasping at straws. Ugh, ugh. No, it timed out. Okay. Let's maybe do the same thing with this for loop. Search from the end of the array and splice there. Yeah. Mert-Jan, I appreciate it. He's saying JavaScript is bound to be slow for these kinds of operations. So in my opinion, you solved it. I feel like I can do it in under 12 seconds though. I think I'll try that though real quick. What JT suggested was searching from the end. Let's do this. Put that back. So we'll search from the end. The moment we find a value less than the value, we'll splice it at I plus 1. Let's try that. Okay, so we'll start I, and then we don't have to keep track of the last insert. We're always just searching from the end. So I will start at sequence dot length -1, while I mean technically while I is greater than 0, but we should find it before then. Greater than or equal to 0, and decrease I. And if sequence at I is less than the value, then we're going to break out, and we're going to splice at I plus 1, because we want to put it after the value that's less than, I believe. Does this still work? It still works. Let's try it again. Oh, not that. Sample test okay? "12 seconds. I'm just too long." Okay, I think I am gonna call it there because I've been streaming for a while. But I'm gonna work on my solution. Next time I'll try to see if I can find something that doesn't time out. Might be something else I can do in here. Okay, one last thing. Let's put this for loop inside instead of making it a function call. Like that. Just Y. Still works. Looked like it might work for a second. Okay. That's okay. I'll figure it out. I'll take a look at your comment too to try to figure out what you're saying to do. Basically, we're calculating what will the next x be and the next y be, pushing in the larger value, and then repeating that process till we get up to n. Okay. Okay, I hate to end it on a non-passing kata, but I have been streaming for a while, so I'm going to end it there. Thanks, everyone, for tuning in. Thanks, JT, for your help. Thanks, Mert-chan, for your help and your suggestions. Thanks, James, for tuning in. I guess you went to sleep. Mayer, thanks for tuning in. Wayne, if you're out there still, see you later. Jackson. Who else? Hope I don't miss anybody. I think Amy, you were in here. Yeah, and Rohit might be gone, but I'll see you later. And Ran, if you're still out there. But yeah, this was a fun time. Rodrigo, yeah, see you later, CJ. I'm reading your message. You say see you, CJ. See you next time. Yeah, and Mert-chan is saying, I am passing 94 tests, failing 0 tests, but it's just timing out. It's just giving me arrays or values that are just way too big. Recursion? Would recursion be faster? I'm done. I'm done for tonight. I'm gonna reassess. I'll take a look at this one next time, and I will definitely get back to you. But thanks everyone for tuning in. Tomorrow morning, I am doing morning tea at 10:30 a.m. Mountain Time, and then tomorrow evening, I am building a Reddit clone with Firebase, Firestore, and Vue.js and Vuex. So you can click set reminder on those if you want to tune in for them. Have a wonderful morning, afternoon, evening, or night, wherever you are in the world, and I'll see you next time. Before we do that, there's my fish, sleeping in his lily pad. All right, I'll see you later.